right, you guys, so we're going to begin our factoring review with looking at this chart. This chart kind of outlines all of the different types of factoring you've learned before and that we're going to be reviewing. Today, we're going to start off with this little blurb on the top right-hand side, which says that the very first step that you do with every single factoring question is you take out the greatest common factor. And I'm going to show you how to do that with the first sheet of lesson. Then after that, in order for you to figure out what type of factoring you're doing, you're going to look at how many terms the question has. Now, when it has 2 terms or 4 terms, those are the easier questions because there's only really one way to factor those. So 2 terms is difference of squares and 4 terms is factoring by grouping, which we'll talk about today. The more complicated ones are the ones where it's a trinomial of 3 terms because there are many different ways we can factor those. So we're going to start simple trinomials today, and then we're going to continue complex trinomials tomorrow. Does anyone here remembering factoring completely and is like an expert and loves it and is so happy we're doing this? Okay, not all at once now. All right, so let's take a look at the greatest common factor. And remember, before we actually start this, what exactly is factoring? So you know how we just reviewed, if we have something like x plus 3 and x plus 2, I can give you a question like this and I can ask you to expand. And when I ask you to expand, that's when you're going to use FOIL. So you would go x squared plus 2x plus 3x plus 4, and then you would clean up the middle sign. So it would be 5x plus 4. This is what we did last week, Thursday, Friday. This is called expanding. So when you're going from here to here, you're expanding. Now what we're going to do is we're actually going to go the opposite way. It's kind of like I'm going to give you the answer, which is the x squared plus 5x plus 4. And I'm asking you what was the question to give you that answer. And this is called factoring. So when you're factoring, you're actually trying to figure out the question, and often brackets are involved. And that's how you know you factored it correctly. Okay, so let's take a look at the first question. It's a common factor. So this is clearly the answer. And we're trying to figure out what the question was. The first step, before we even look at the terms, is we're going to take out the greatest common factor. And the greatest common factor, I look at it as the coefficient and the letters or the variables. So if you take a look at all of the coefficients, you have an 8 and a 6 and a 4. What number is common between all of those? To practice your names, Kareem? Yeah, the number 2 is the highest common factor between all of them. Another way to think about it is if you have your multiplication table, actually, no, don't think about it that way. 2 is correct. That's what we're going to go with. So we're going to factor out a 2. That's what I'm going to write. Then I'm going to start looking at the letters one by one. I have an x cubed, an x squared, and an x squared. What is common between all of them? For sure, it's an x, but is there something a little higher, Justin? Yeah, we know for sure there's an x squared in the first term, an x squared in the second, and an x squared in the third. It just so happens that the first term has x cubed, so it has a little bit more x left in it. But the common factor is x squared. That's what we're going to factor out. Okay, now let's look at our y's. We have nothing in the first term. We have a y squared in the second term, and we have a y all by itself in the third term. So what's common between all of them? Is a y common between everything? No. So in this case, you can't actually write a y because the first term doesn't even have it. So we're not going to include the y in our factor that we're taking out. So we think the greatest common factor is a 2x squared. So we're going to work backwards. We're going to say, okay, 2 times what number here is going to give me the number 8? Yep, that one's pretty straightforward. It's going to be a 4. Then we're going to do the same thing again with the x squared. So x squared times what here is going to give me x cubed? X, good. So I'm going to go ahead and write an x over here. Is 2x squared times 4x 8x cubed? Yeah, so that means we've done that part correctly. We're going to move over to the next term. Okay, for the next term, we have 2 times what number here is going to give me a negative 6? So 2 times what gives negative 6? I accidentally said it. Yep, negative 3. X squared times what is going to give me an x squared? It's kind of a trick question. It's just the number 1. Do we need to write down a 1? No. So we kind of just leave it. Leaving it doesn't mean it's a 0. So don't be confused with that. If you don't write anything, it's actually a 1. And then we don't have anything outside the bracket. So 1 times what is going to give me y squared? Y squared, yeah. So I'll repeat that part again. It's kind of like saying 1 times y squared is going to give me a y squared. Okay, now we don't have to write the 1. We just know that it exists. All right, let's do the last term. So again, we start off by looking at this. So 2 times what number here is going to give me a positive 4? 2. X squared times what will give us an x squared? 1, we don't need to write that down. And then 1, so again, you pretend there's a 1 here, times what is going to give me a y? Y, it has to be a y. I don't know if it helps to learn it this way or explain it this way. I do find that going step by step, like first looking at the number, then looking at the variable, has success because you can very clearly see what's happening. Does anyone have any questions about that? And does it seem familiar? No? Okay, a little familiar to some of us, maybe? Yeah? Okay, I see a couple of nods, so we're going to keep going. Let's go ahead and try question number 2. I'll give you guys a second to do that while I do attendance. All right, we're ready for question number 2. This one's actually easier than question 1. Between 4, 2, and 8, what is the greatest common factor there?
2x.
And yep, and then you notice that there is an x in each term, so you're going to take out an x. Does anyone want to raise your hand, volunteer, and tell me what everything inside the bracket would be?
Can I?
Okay, we'll do one person in class and one person virtual. So Kevin, go ahead. Good, and then was it Denoya who was volunteering?
Yeah.
Go ahead,
I
Denoya.
got 2x bracket 2x squared positive x minus 4 bracket.
Okay, so you're close. We have a 2x squared, and then it should be plus x, and then it should just be minus 4. Because now if you were to distribute, what the heck is happening here? If you were to distribute this, you would get 2x times 2x squared is 4x cubed.
Yeah, that's what I got.
Oh, good. I think I just misheard you. All right, let's go on to the next type. It is a binomial common factor. So for this, I'm just recording. Let me pause for a second. Okay, so we have a binomial common factor. What exactly does that mean? Well, if you take a look at both of those terms and I ask you what is common between both of them, you're going to notice that w plus 1 occurs in both of the terms. So now what we're going to do is the same thing as before. It's just this time it looks a little bit more complicated. So we're going to factor out the w plus 1 because it's common between both of the terms. And then we're going to ask ourselves what is left over. So w plus 1 times what is going to give me this entire term up here? So w plus 1 times what is going to give me 4x times w plus 1? Kevin? Yep, exactly. It would just be a 4x. And then we're going to do the same thing for the second part of the bracket. So w plus 1 times what is going to give me this? And we can see that it has to be a 5y. So now if you were to redistribute this, you would just take the w plus 1 and multiply to the 4x to get the first term, w plus 1 times 5y to get the second term. Go ahead and try this with the second question. It's the same thing, a binomial common factor. Okay, I shall do it as well.
Can you scroll up?
Yes. All right, you guys, so here is where we have a question, which is a factoring by grouping question. If I can get your attention for 1 second to this chart, we're going to look at the part that says 4 terms. Eventually, there's a huge lag today. The internet is not doing very well. Well, you have your sheet in front of you. So take a look at where it says 4 terms, and it says factoring by grouping. So whenever you have a question with 4 terms, usually you're going to have to group something together to factor it. There's a little helpful hint here for you. Find the greatest common for the first 2 terms and the last 2 terms, and then try to factor it. So let's go ahead and actually try this. Okay, so there are actually multiple different ways to do this question. You can rearrange the terms if you wanted. You can keep them as is. Sometimes it works, sometimes it doesn't. I'm going to show you the strategies I use, and you can see if they're helpful or not. So the first thing I'm going to do is I'm going to group the first 2 terms together and the second 2 terms together. And then I am going to look at the first 2 terms and ask myself, what is common between both of those? What letter is common? C. So I'm going to factor out a C. And I'm going to be left with A plus B. Everyone with me? Yeah? All right. For the second 2 terms, I ask myself again, what is common between both of them? The letter D. And when I factor out a letter D, I'm left with A plus B. What does that question remind you of now? That is a binomial common factor, exactly what we just did. So we look at both of these terms and we notice an A plus B is common between both of them. What would be in our other bracket? C plus D. Now I have to tell you guys that factoring by grouping, like 95% of the time, it'll work out really nicely the way the question is written. The other 5% of the time, you're going to have to rearrange the terms just a little bit, especially if you try the textbook questions. I noticed that they do that. Let's go ahead and try question 2. Actually, you guys try it, and then I'll write the solution on the board, and we can check to see if we get the same answer. Now, you know, I'm like a part-time mind reader. I know exactly what you guys are saying. You're saying, I'm really rusty at this. I need 36 questions to practice. So if you turn to the back of the page, oh, sorry, 27. Oh, the other page is 36. If you go to the back of the page, handout A is 27 questions of greatest common factoring that you're going to try. Now, again, use your discretion. If you are an expert at factoring, you can pick every other one. If you don't remember anything, you should do every single one. We're not done. We still have to do one more lesson. Before we go on, I just want to bring your